Hello and welcome. Today, we're going to dive into one of the most powerful tools in all of statistics, regression analysis. We're going to find that clear, simple path right through what at first glance just looks like a total mess of data.
And I want to officially welcome you to the Tao Salon for statistics. Look, the goal here isn't to get bogged down in a bunch of complicated formulas. It's about finding the flow, that underlying story that our data is desperately trying to tell us. It really is all about finding clarity in the chaos.
Okay, let's jump right in. This is our central puzzle for today. What you're looking at is a scatter plot, a cloud of data points, for 218 used BMWs. You've got the price on the vertical axis and the mileage down on the horizontal. You can kind of see a trend, right? As the mileage goes up, the price seems to go down. But can we be more precise than just seems to?
Yeah, that's the real question, isn't it? It's not enough to just say, more miles, less value. We want to know exactly how much value is lost for every single extra mile on that odometer. And that is precisely the kind of question that regression analysis was built to answer.
So to find our answer, we're going to use a tool called simple linear regression. And its whole job, its entire purpose, is to draw one single perfect straight line right through that cloud of data points. It's all about finding the signal in all that noise.
So what is regression analysis, officially? Well, it's a statistical method for figuring out the relationship between two variables. In our case, the thing we want to predict, the price of the car, that's our dependent variable. And the thing we think is causing the change, the mileage, that's our independent variable.
Let's get back to our data puzzle. We've got these 218 cars, and every single one is a dot that represents a specific price and a specific mileage. This is a classic business problem, right? How do you price a used car? You can't just guess. You need a system.
And here it is. This is the solution in action. The regression model calculates the one straight line that best fits this data. And it does that by minimizing the overall distance to every single point. So in a way, this line, it becomes our model of reality.
Now, drawing the line is great, it looks cool, but the real power comes from the numbers that actually describe this line. These numbers are what let us decode the relationship between mileage and price with some pretty incredible precision.
So the first key number is something called the regression coefficient. It's just a fancy name for the slope of the line. It tells us exactly how steep that line is. In our car example, it's going to tell us precisely how much the price changes for every 1 mile increase in mileage.
And here's what that actually looks like in the real world. Based on the data, our model tells us that for every extra 1,000 miles you put on one of these BMWs, its price is expected to drop by about $240. All of a sudden, that vague trend is a concrete, actionable number.
All right, time for our second key number, r squared. In this case, it's 0.42. But what on earth does that actually mean?
R squared is basically our goodness of fit measure. An R squared of 0.42 means that the car's mileage explains about 42% of the reason its price is what it is. And here's the key insight. Our model is definitely useful, but it's not the whole story. Other things, like the car's age, its condition, maybe even its color, they make up the other 58%.
So we have this powerful model. But like any powerful tool, it comes with some pretty serious warnings. We have to use it wisely. There's power here, but there's also peril.
Broadly speaking, there are two big things you can do with a model like this. The most common is prediction and forecasting. Like predicting the price of a car. The second thing, and you have to be really careful with this one, is trying to infer that one thing actually causes another.
So when we're making these predictions, we have to know where the model is on solid ground and where it's, just guessing. So how far can we really truly trust it?
This slide really gets to the heart of it. It's the difference between a safe prediction and a dangerous one. Predicting the price for a car with 40,000 miles, totally safe. That's right in the middle of our original data. But trying to predict the price for a car with 150,000 miles, that's called extrapolation. It's way outside our data range. And honestly, we have no idea if the same relationship still holds true way out there.
This quote really just sums it up perfectly. You cannot assume a pattern continues forever. It might not. A car's price might not keep dropping at the same rate once it becomes a classic, right? You've got to stick to what your data actually knows.
Okay, so let's bring it all home. How can we put all this to work? If you're in business or marketing or research, it really boils down to 3 key takeaways.
First, quantify your relationships. Stop using intuition and saying, more ads probably leads to more sales. Start saying, every $1,000 in ad spend generates an estimated $4,200 in sales. See the difference? Second, measure your confidence. That R-squared number tells you how much of the story your model is really telling. If it's low, you know you need to look for other factors. And third, forecast with caution. Absolutely use your model to predict the future, but never, ever, ever extrapolate beyond the world your data lives in.
You know, in the end, regression analysis isn't just a formula. It's a way of thinking. It's about finding that clear, simple flow in a really complex world. So the only question left is, what hidden relationships, what hidden flows in your own data are you ready to uncover?